All right, good morning, college algebra students. Today we're going to learn about geometric series. Last week we learned about arithmetic series. So again, series means you're going to add up things from a list. We're going to start at the first term and stop at the third term. And this expression is going to look like this. 4 times 3 to the power of n minus 1. So when you have such a small amount of things on your list, in other words, we're only adding up 3 things, I'll just visualize like this: first term, second term, third term. It shouldn't be too hard to do this math. Remember, we're going to put a 1 in there, and then a 2 in there, and a 3 in there. So when we put a 1 in there, we get 1 minus 1 is 0. 3 to the power of 0 is 1. And 4 times 1 is 4. So this should look familiar. We should be able to recognize this is an explicit form of a geometric sequence, which helps us look at a list. Now this expression right here just means we're going to add it up. So when I put a 2 in here, friend, 2 minus 1 is 1. 3 times 3 to the power of 1 is 3. 4 times 3 is 12. We should recognize really that we're starting at 4 and we're constantly tripling. We should be able to predict that this next term is 12. If you fail to see that, when I put a 3 in here, 3 minus 1 is 2. 3 squared is 9, and 4 times 9 is 36. So in DDO it is this expression here, which is 52. You could add this up the old-fashioned way. The problem is that you cannot use the rainbow technique. That does not work. That only works for arithmetic. The way you add these things up, if you had a much longer list, let's say I asked you to add up the first 30 or 300 terms, there is a shortcut. There is a formula. So I'm going to show you what it would look like to add up the first 3 terms. The sum of the first 3 terms is your first term, that's 4, times the quantity, 1 minus 3, because we're constantly tripling. This is your ratio. And also to the power of 3, because that's how many terms we have. And down here, 1 minus your constant ratio. All right, now I know that's a lot of parentheses. If you were to do all this math, which you could, you would get 52. And I have evidence of that here. In this first expression, we simply just added the sum of those guys and got 52. Then I threw in this expression. Again, you really should have parentheses around the 3. You got 52. So if I wanted to change this up a little bit, I'll show you what would happen. If a question asked us to find the sum of the first 30, what I would do is start with a list. Start with the first few. Putting a 1 in there gives me 4. Putting a 2 in there gives me 12. Putting a 3 in there gives me 36. So now I recognize I don't want to list all these out. In fact, you don't. You don't even have to calculate the last term. The few things you need to find a sum of n things is your first term from this list, which is 4, 1 minus your constant ratio, which in this case is 3, to the power of how many things you have on this list, which is n, or in this case, it's 30. And then you're going to divide by 1 minus your constant ratio, again, which is 3. So for this specific one, it would look like this. The sum of the first 30 things is your first term times the quantity, 1 minus your constant ratio, 3, to the power of 30, divided by 1 minus your constant ratio, which is 3. So the difference between that, let's say the sum of the first 300 terms, the only difference is that 30 becomes a 300. That's the only difference. And again, you can see all this information by listing the first few terms. You could recognize, okay, our first term is 4, we're constantly tripling. We know what our constant ratio is. Now we just need to see, okay, we're finding the sum of 30 things. So just for fun, I'm going to show you what you can do. If you have access to one of these calculators, you copy and paste that. You could just now change 3 to a 30, and it's a huge number. I'm going to do one more problem with you guys. In this instance, we're going to find the sum of the first 4 things from a sequence that starts at 50 and constantly multiplies by half. You should be able to recognize this. Again, you put a 1 in there, you get half to the power 0 is 1, and you end up with 50. Your first term is clearly 50. And then we're constantly multiplying by half, 12 and a half, 6 and a quarter. All right. When you have such a small finite group, a list here, it probably is just easiest to add it up the old-fashioned way. Just work left to right. This is 75. That's 87.5. Tack that thing on. You're getting close to 100. But I do just want to confirm that this formula would work. This is the sum of the first 4 things on your list, where your first thing is 50, and your constant ratio is, in this case, half to the power of 4, and 1 minus half. So I'm going to go here just to work through it again. In this case, I'm going to change my exponent to 4. I'm going to change my constant ratio to half. I'm going to change my first term to 50. And down below, change my constant ratio to half. You can use decimal as well. So that would be the expression. Remember, they tend not to give it to you in decimal unless you ask for that. So 93.75. That's how that would look. So the sum of the first 4 is 93.75. Seems reasonable. Now I'm going to show you what happens if we wanted to find the sum of the first, let's say, 40 terms. Remember, as you move to the left here on this, or pardon me, on the right on this list, so now we're going to add up the first 40. These values that you're adding are smaller and smaller and smaller. This is 3 and an eighth, etc., etc., etc. By the time you get to the 40th term, you're barely adding anything. You're hardly adding anything to the list. So now all I need to do is copy and paste and change my 4 to a 40 and compute this as a decimal. And it's I'm going to give you a hint here. It's not quite 100. It's almost 100. My calculator has rounded. But if you do a calculation and you get 100, you could write that. I just want us to recognize that occasionally the number is so close to the outcome that they just round up. That is the assignment for today. I'd like you to take notes.